Hello and welcome to another edition of the Healthy Food Show podcast. Today we are talking about sourdough bread. If this is another instalment about a fermented food, and sourdough bread is made using a natural fermentation process that involves symbiotic culture of wild yeast and lactic acid bacteria. These microorganisms are present in the sourdough starter, which is a mixture of flour and water that's been allowed to ferment naturally over time. The microorganisms responsible for the unique flavour, texture, and leavening of sourdough bread include wild yeasts and lactic acid bacteria. The wild yeasts that are present are naturally occurring fungi that ferment the carbohydrates in the flour, producing carbon dioxide and alcohol. Fermentation process causes the dough to rise and contributes to the bread's flavour and texture. There are three main yeasts that tend to be present in different sourdough breads. The first one is Saccharomyces cerevisiae. It's probably the most common yeast. Although this species is commonly associated with commercial baker's yeast, it is also found in wild sourdough cultures. It is a robust yeast that ferments sugars efficiently, producing carbon dioxide and helps leaven the bread. Candida milera, also known as Candida humilis, this yeast is well adapted to the acidic environment of sourdough. It works in harmony with lactic acid bacteria to ferment the dough, contributing to the leavening and complex flavours. Saccharomyces exiguus, another wild yeast often found in sourdough starters, and is less tolerant of the high acidity than Candida milera, but still plays a role in the fermentation process, particularly in the early stages of the dough development. Other type of organisms that are present are lactic acid bacteria, and this is what makes sourdough different from ordinary bread. The lactic acid bacteria are responsible for producing lactic acid and acetic acid, which gives sourdough its characteristic tangy flavour, hence its name. These bacteria also contribute to the preservation of the bread by lowering the pH, which inhibits the growth of any spoilage organisms. There are four main lactic acid bacteria that are present. Lactobacillus sanfrancisensis, named after the city of San Francisco, where sourdough bread is famous. This bacterium is one of the most important lactic acid bacteria in the sourdough fermentation. It produces both lactic acid and acetic acid, contributing to the bread's sour flavour and overall stability. Lactobacillus brevis is another bacteria, and this lactic acid bacteria species is also commonly found in sourdough starters. It ferments sugars into lactic acid, contributing to the sour taste and helping to preserve the bread. Lactobacillus plantarum, found in many fermented foods, is another lactic acid bacteria that can be present in sourdough. It helps in the production of lactic acid and may also contribute to the development of the flavour and the texture. Lactobacillus casei, occasionally found in sourdough starters, produces lactic acid and has potentially probiotic benefits, though its role in sourdough is mainly related to the flavour development. Now, you can also find acetic acid bacteria. While not as prominent as lactic acid bacteria, acetic acid bacteria can also be present in sourdough starters, contributing to the overall acidity and the flavour. And the main species is Acetobacter. These bacteria produce acetic acid from ethanol, adding a sharp, vinegary note to the flavour profile of the sourdough. So, the fermentation process and microbial succession includes the following. The fermentation process in sourdough involves a complex interaction between yeast and bacteria. The initial fermentation, when the flour and water are mixed to create the starter, wild yeasts and bacteria from the flour, air and environment begin to ferment the mixture. The yeast produce carbon dioxide, causing the dough to rise, while the bacteria produce lactic and acetic acids, lowering the pH and creating the sour flavour. So the microbial balance, as the starter matures, a stable community of yeasts and lactic acid bacteria develops. The yeast and bacteria coexist in a balanced relationship, with the lactic acid bacteria producing acids that create an environment favourable for acid-tolerant yeasts, like Candida miliaria. Dough development. So the mature starter is mixed with more flour and water to make the dough. The fermentation continues. The yeasts leaven the dough, while the lactic acid bacteria continue to produce the acids, enhancing the flavour and texture of the final bread. So there are factors that influence the microbial composition, and these are the following. So flour type. The whole grain flours such as rye and whole wheat and often contain more wild yeasts and bacteria than refined flours, influencing the microbial diversity. The water source. The mineral content and the pH of the water can affect the growth of the yeast and the bacteria. And the environmental conditions, so this is the temperature, the humidity, and the presence of other microorganisms in the environment, can all influence the species dominate the sourdough culture. And the feeding schedule. Regular feeding, which is adding fresh flour and water, promotes the growth of a stable microbial community. In conclusion, the sourdough's unique flavour and texture and leavening properties result in a symbiotic relationship between wild yeast and lactic acid bacteria. Saccharomyces cerevisiae and Candida miliaria are key yeast species responsible for the rise, where the Lactobacillus sanfranciscensis and other lactic acid bacteria contribute to the sour flavour and the preservation. The balance and interaction of these microorganisms create a complex and delicious bread that has been enjoyed for centuries. So I hope you enjoyed our quick introduction to sourdough, and if you would like to share and follow our channel, please do so, and please tell all your friends to watch. Hope you enjoyed it and hope to see you soon. Bye.